of waveguide and coaxial connector is there. So I will just zoom it. Now you can see that the circular structure is nothing but the coaxial cable, you can say. Actually, it's a connector, but you are more aware with what the coaxial cable. So it's a medium to connect the cable with this the structure which is shown on the bottom side of this cylindrical structure. So you can see that on that rectangular structure, it is written as 8.2 to 12.4 gigahertz, and the middle line it is WR90. Okay, so this rectangular structure is nothing but the waveguide, and the band for which this waveguide can be used is from 8.2 gigahertz to 12.4 gigahertz, and it is called as what? X band. Okay, so micro frequency actually starts from 1 gigahertz and it goes to 300 gigahertz. So one of the band in this entire range of frequency is called as X band, which ranges from 8.2 gigahertz to 12.4 gigahertz. But there are other waveguides which can support lower frequency than this or the higher frequency than this. Now, why I'm showing this? Because this is the waveguide which our college is having. That's why purposely I'm showing this. Now we are going to see how this this entire thing is going to work. Okay, this rectangular, what is the theory behind this rectangular structure and why it is important to discuss. Okay. Now I will start with the theoretical background of this waveguide. So for which I will be using this app. It's a whiteboard. Okay, so see, to understand this waveguide, it is important to understand what the transmission line is, and that transmission line, that topic was covered in the last semester itself. So I hope that you remember little part of that. Not the entire is not expected, but little part of that is expected. So I will just recap it little bit, all the relevant thing which is required to understand the waveguide. So we are knowing that if a transmission line is taken, like suppose this is a transmission line, and the kind of transmission line to which you are aware is what? It's a two conductor transmission line. So this is a transmission line which is shorted at the end. On the right hand side, you can see that it is shorted, right? So here, this part, this is what? Short end of the waveguide. Now if I, sorry, transmission line. Now if suppose I connect a here a source, okay, so, and it's AC source, and let us consider that the length of the transmission line is around L meter. Okay, since the right hand side of the transmission line is short circuited, so what is going to happen, that whatever power is transmitted with this source or generator, you can say, then that power will transmit, it will travel down the transmission line. The moment it reaches to the end of the transmission line, at this end, then short circuit means you are knowing that it is impedance is 0, whereas the impedance of the transmission line, that is the characteristic impedance, suppose 50 ohm. So there will be a mismatch in the impedance, and because of which the power will get reflected back. So now there will be two kinds of power which are traveling on the transmission line. One which is coming from the generator side, and one which is coming from the load side. And these two power, they will collide with each other. And if you look at the voltage quantity and current quantity, because these are the two quantities which are phasor in nature, they are vector quantity. So what is going to happen, that we'll draw the graph here. So this is the dead end of the transmission line, right hand side. From here, if I draw the pattern of the two waves when they collide, which is called as what? Standing wave. So it will be something like this. Okay, so this is nothing but voltage representation of the along the line. And if I look at the current, so of course the short circuit is there. It means that the current has to be what? Maximum. So the current will be something like this. This is the standing pattern of the current. So now you can see that there is what? Phase difference of 90 degree between the voltage quantity and the current quantity, right? So if we'll take the product of this to find out what power. So VI and cos phi. Phi is what? The angle between these two. So it is going to be what? 0. Means the dissipation of the power is going to be 0. So, but since the voltage and current both are existing, then what kind of power is actually available in the transmission line? So we call this power as what? Reactive power. It is stored in the transmission line, but it is never ever dissipated. Dissipated means the loss of this power is not going to occur because there is nothing like lossy resistance. Okay, so just keep this standing wave in nature, or the standing pattern of the voltage and current, because this is the key to understand the working of waveguide. Okay. Now we'll move to the next slide. So here we will start with the waveguide. So to understand the waveguide, how does it work actually, and how it is different than the earlier transmission lines. So remember that whatever transmission lines you are introduced with, all are having multiple conductors. Multiple conductors means at least 2 conductors are there. And if such is the case, then any transmission line where the multiple conductors are there, these conductors or these cables can carry DC and AC both. But waveguide is designed in such a way that it is going to deal only with the AC. If you're trying to send DC, it's not possible. But why it is not possible, that you will get the answer after the end of this topic. So for to understand this waveguide, let us start with a 2 conductor transmission line, because you are aware with that. So we'll start with the 2 conductor transmission line, and it will be modified to a waveguide. Okay, so transmission line you are aware, that's why I'm taking the help of this, and it is simple to understand. Okay, let us consider that this is the 2 strips which comprises of conductor, and it is excited with AC source. Okay, so if I look from the front side, so it is going to be what? Top plate, bottom plate, and a source in between. This is how it is going to look like. So even if the frequency is 0, then also this transmission line is capable to carry the power from this end to this end, means in the forward direction. And if suppose you are dealing with the AC source, then also this transmission line is capable to transmit power from the left hand side to the right hand side if it is loaded. Okay, with a load or L. And any transmission line having some cross-sectional dimension, it will have some characteristic impedance, so which we call as what? Z0. Okay. Now, if suppose what is going to happen if I now the problem with this kind of transmission line is what? These transmission lines, they have got upper limit. Upper limit is what? Any transmission line which is a combination of what? Multiple conductors. So as I said that it can carry DC power also. It means that the frequency is 0 of that particular signal, means that DC signal. So even if you increase the frequency, then also these transmission lines, they are going to carry power from the generator to the load end. But unfortunately, there will be upper limit. Upper limit means what? Beyond that frequency, if you are trying to operate this transmission line, then there will be a lot of radiation. A simple reason is what? The transmission line is going to behave like antenna. And of course, it is not expected from any transmission line, because if the power is getting radiated, and as the frequency increases, this radiation loss is going to increase and increase and increase. And finally, delivery at the lower end, it will fail, or it will be so poor that finally you will scrap this kind of transmission line. So now what option is left? So finally, this waveguide was introduced, that this kind of transmission line can carry power to a longer distance without any loss at higher frequency. So basically what I'm trying to say, that multi-conductor transmission lines, they are their behavior is what? Like low pass filter. So you can call this as low pass filter. Okay. Whereas the waveguide, it behaves like high pass filter. Now, how it is going to behave like a high pass filter, and how it avoids the radiation loss. So for that, let us move ahead. Now what I will do, uh, to this existing transmission line, which is comprising of upper strip and the lower strip, see, you can choose any shape. It's not necessary that it should be what, flat. It is just for the sake of understanding. Actually, it's a coaxial cable only, okay? But I have modified it to have two separate conductors, just like parallel wire cable. Now what I will do, I will short this transmission line, that is the upper transmission line and the lower transmission line, with the help of a thin wire like this. Okay. And on the other side also, I will do the same thing like this. So if I look it from the front side, then the structure will look like this. Right. And in between this red portion of the transmission line, a source is there. Okay. And now let us consider that the width of the middle portion, there is W. Okay. Now, the moment you connect this two transmission line on the left hand side and the right hand side of this strip, then this strip, I will shade it so that you won't get confused. Okay, like this. These are the connections. So with this red strip is actually responsible for carrying the power from the left hand side to the right hand side, that is from generator to the load end. But the moment you connect this two thin short circuited line on the left hand side and the right hand side, like shown in this figure, then what is going to happen, that whatever current which was actually going in the forward direction towards the load, now there will be two more components of the current. One, it will be moving on the right hand side, and the other, it will be moving on the left hand side, because the current now, it's a junction. Okay, here a junction has got created. So one current will move in the forward direction, another on the left hand side, another on the right hand side. So what is going to happen now, these two transmission lines, the black one, okay, since this is what short circuited and you're dealing with the AC source, so what is going to happen, that now the earlier discussion of our standing wave, so that is what is going to happen. Let us consider that the length of these two lines, black lines, they are such that the standing wave which has got formed here, it will be something like this. Okay. This end here, it is short circuited, so you can see that this is voltage minima, and as you move away from the short circuited end, and if you are moving towards the generator, then the voltage is going to increase. So I will redraw it here like this. This is the middle portion. Okay, the standing wave, it has got formed like this. So you can see only quarter cycle is formed, not a multiple cycle, just like this. Why? Because the length is that much. That's why. And now here the source is present at the mid. Okay. Now we will see what happens if the frequency. See, this wave generator, sorry, the generator, it is operated at certain frequency, and because of that frequency, you will get what, certain lambda, and that lambda is such that the standing wave which is formed in the additional transmission line, this length is what, it is exactly equals to what, lambda by 4, and here also this length is what, exactly equals to lambda by 4. Okay, so only quarter cycles are formed on the left hand side and on the right hand side. But if I increase the frequency, then what is going to happen? So if frequency increases, then what happens that wavelength decreases. Okay. So because of which, what is going to happen that we will reconsider the same figure here. This is the short circuited lines. Okay. And on the right hand side, the short circuited line. Now this is what physical structure. So physical structure, once it is manufactured, it is not going to change. But of course, the frequency, that totally depends on the generator. If you are having a generator whose frequency, magnitude, everything can be changed, then wavelength can be adjusted. Okay. But of course, the transmission line, because it is a uh, once it is manufactured, it cannot be changed. Sorry. So what is going to happen now if the wavelength reduces? So what is going to happen? Sorry, this will not be the fruitful discussion. I will reverse the case here. Frequency reduces, and because of which the wavelength increases. Okay. So what you are doing now, that you are adjusting your generator, which is connected at the mid of this system of the lines. So if the wavelength increases, then what is going to happen? See, the width is what of this center line is what W, which is responsible for what carrying the current towards the load. Now, if the frequency reduces and because of which the wavelength increases, so the short circuited line on the left hand side and on the right hand side, they are going to what contribute in what standing wave. So in earlier case, the frequency was such that the standing wave which was getting generated, it was something like this, right? The maximum it reaches or it touches the edge of this W strip. Okay. But if suppose the frequency has got reduced, the frequency reduces, then the wavelength is going to increase. So what is going to happen to the standing wave? So what happens that since this end and this end, they are what short circuited end. So the voltage minima, it is going to exist here only. But what is going to happen to the maxima? So in earlier case, the maximum was occurring here, and the W width, it was kept as it is. But if the wavelength increases, then what is going to happen? That still the minima will exist there only, there itself. I will use the black color. So once again, because it's a AC source, short circuited transmission line, so standing wave will get formed. Now the standing wave, see the maxima, it will get occur somewhere here because the wavelength has got increased. And from here also, now here. So now you can see that the maxima this time they have occurred here and here. So even though the physical width of the central strip is what W, but for wave, now the width of the strip, it has got reduced. It is now this much. So earlier if the width was this much for the wave, now the width for the next wave, whose wavelength is larger, now it is this much. So what is going to happen? That since the effective width, which was earlier this much, now that effective width, it has got reduced. Okay. So if the effective width has got reduced, so the current carrying capability of the strip, that will get reduced. But the generator is same, so it means that it must generate the same power. So what is going to happen to the current actually? Whatever current is fails to move in the forward direction. So all the current means the current on the right hand side, current on the left hand side, that will keep increasing, and the current on the towards the load, that will keep reducing if you keep reducing this frequency and the wavelength increases. So finally what is going to happen? You will reach to a situation where the wavelength, it has increased to such an extent that the standing wave, which is formed in this three transmission line system. So the minima is going to occur at the same place because a short circuit is occurring on the left hand side and the right hand side. So the location of minima will not get disturbed. Okay, but the maxima, that will keep shifting. So what is going to happen now? You can see that the maxima is exactly formed at the mid of the this strip, whose width is what? W. So now you can see that width W has got completely vanished. It means that now there is a theoretically you can see that there is a thin line which is responsible for carrying the power. But if you suppose reduce the frequency further, and because of which the wavelength increases further, then the standing wave will be something like this. It will start, minima will start from here, and the maxima is going to occur somewhere here, and the maxima is going to occur somewhere here. Okay, which is not possible actually. So what is the final conclusion? That there is something called as what? Cutoff wavelength. That is what? Maximum wavelength which can for which there can be what? Flow of power from source to the load side. And any this wave which is what operated at such a larger wavelength, it is called as dominant mode. Okay, means what? This transmission line cannot be operated for any wavelength which is what? Larger than this lambda c. That is called as what? Cutoff wavelength. Maximum wavelength, that is okay, but technically it is cutoff wavelength. Okay, so cutoff wavelength is the highest wavelength which can travel in this transmission line. But if we'll try to use this waveguide at a wavelength which is what? Larger than this cutoff wavelength, then something what? This is what is going to happen. That transmission line, it fails to accommodate that this cycle. So you can see only half cycle. Your field distribution or the standing wave should be in such a way that it should support maximum, this kind of this voltage distribution. That is going to happen only at cutoff wavelength. So if the wavelength is further increased, then the boundary condition is going to fail, and this waveguide is not going to support that signal. So that's why waveguide they work like what? High pass filter. You can operate this waveguide at any higher frequency whose wavelength is what? Maximum equals to lambda c or smaller than lambda c. So it can be written as that operating wavelength is always less than or equals to lambda c. This is the condition. So if you are going to operate your waveguide at larger wavelength, then it is not going to work. That's why it's a high pass filter. Okay. Now we'll move further. So in the earlier diagram, I showed that you are having what? Strip like this, and I said that okay, two strips, top and bottom, right? And I said that these two strips, they are what? Shorted on each side. Okay, like this. So if I suppose have such large number of this wires, and if the distance between each this wire is reduced to 0, then what is going to happen? You will get a closed structure like this. Okay, this is what you are going to have at the end. So if the structure is closed, your entire EM energy, it is trapped in this closed structure, and there won't be any radiation. Okay, so radiation from the transmission line is what? 0. But condition is what? That you should operate waveguide as per the requirement. Means the operating wavelength should not be more than lambda c. Then only it is going to happen. Otherwise, the radiation may take place. Now, there are certain formulas which we are going to use. But before that, we'll talk on modes. Okay. So, what I said that we'll take the front view. View of the waveguide. So this is the front view of the waveguide. Okay. Waveguide is a flow structure whose nature is what? Like a high pass filter. Okay. And if suppose this waveguide is operated at largest wavelength, that is what? Cutoff wavelength, then the distribution of the voltage will be what? Something like this. Right? Just now we discussed. This is the mid of the okay. So this is the mid of the waveguide. So you can see that the peak of the voltage, it exists at the center. Just now, before we discussed that left hand side and right hand side, the two transmission lines are there. And if you are operating your waveguide or system of these three transmission lines at a largest wavelength, which can be supported by this transmission line, then the standing wave, it will be something like this. Quarter wave on the right hand side and quarter wave on the left hand side. So when these two are clubbed, you get what? A length of what? Lambda by 2. Or you can say lambda c by 2. Okay. Now, in technical field, this dimension, they are named as what? This is called as B, and this is called as A. Means the width of the transmission line waveguide is represented with A alphabet, and the height of the waveguide is represented with the help of what? B alphabet. Okay. So, and there is relation between A and B, that B there is equals to A by 2. Okay. Now, before going to relate these things with the data sheet which was shown to you earlier, we'll talk on modes, waveguide modes. Okay. Modes are nothing but the field pattern or the fashion in which the fields arrange themselves in the closed structure of the waveguide. That is nothing but the modes. Okay. So here I said that this distribution, this distribution of the signal on the left hand side and on the right hand side is nothing but the voltage variation. Okay. So you can see that if I now when we talk about the modes, so there are various modes like TE modes, and there is another mode which is called as one more thing, TE, M and N. Okay, and TM, M and N modes. Now this M is nothing but number of half cycles along the x-axis, and N is the number of y-axis. Okay. Now x-axis means what? This. Okay, and y-axis is this. Now m and n both are integers. So m can range from 0, 1, 2, and any larger number. And similarly, n, it can range from 0, 1, 2, 3, and any larger number. Okay, but the meaning of m is what, or n is what? This you have to keep in mind. Number of half cycles along x. Okay, and n, number of half cycles along y. Okay, these two, number of half cycles, will decide what kind of mode is there. So let us understand what is TE and how it is different than TM, and after that M and N. So that will cover the idea about the waveguide. Okay, so but before that we can recap things. So I started with a transmission line. I said that if a transmission line is there and it is operated with AC source, one end is short circuited, or there is a mismatch between the load impedance and the characteristic impedance of the transmission line, then standing wave gets formed. For a short circuited line, at the uh, at the load end, the voltage minima is going to occur and the current maxima is going to occur. Phase difference between the voltage and current is 90 degrees, so power loss in the transmission line is 0. And after that, we move to what? Uh, we related that transmission line, the basic transmission line, with a waveguide. So I said that transmission line, basic transmission line, comprises of two this conductors, upper, lower conductor, and then that is added with what? This black short circuited line on the right hand side and on the left hand side. Okay, and then we discussed, if a source is connected to this three transmission line system, then there will be three different currents flowing. Two currents will be on the left hand side and right hand side, and one current will be on the in the forward direction, which is responsible for sending power from generator to the load end. Whereas the other two currents, you can say that they are not moving in the direction of what? The load. So these can be termed as what? Reactive power. Okay. Now, after that, it was shown that if your transmission line is operated at smaller and smaller frequency, then the standing wave, it gets shifted. The maxima, the minimum of the standing wave, it is going to remain at the same location. That is what at the shorted end. Okay, and the maxima, it moves towards the mid of the main line. That is what? This center line here, this part. Okay, so this maxima, this is the maxima. If the wavelength increases because of the reduction in the frequency, then the standing wave, it keeps shifting, and finally the two standing waves, they will merge and will form one half cycle. Okay, and here finally it was concluded that the moment the two quarter cycles, they merge to form a single half cycle, then the effective width of the central strip, that vanishes, and there is possibility that the delivery of the power from the generator to the load is going to fail. So that is the limiting case, you can say. So this is the maximum wavelength for which the delivery of the power can be made from the generator side to the load end. Okay, and that's why it is called this waveguide is called as what? High pass filter. So waveguide is a closed structure, or you can say a single conductor system, and it behaves like a high pass filter. Okay, and now we move to what? Modes. So you can take 1 or 2 minutes, 1 minute, to just revise things. If any doubt is there, you can ask. So Now I know that TE mode is there, but whether it is 10, 11, 20, 22, 3, 4, whatever it may be, how to identify this? So for that, it is really important to know the distribution of the field. Now what I will do, I will start from this x equals to 0, and I will move to what x equals to a, because that is the width of the waveguide. Okay, and I plot the variation of what the electric field from 0 to a along x-axis. So I will say that at 0, that is at the left hand side, the field is 0. But as I move towards the right hand side, the field increases. Okay, at different distance, the field is what different. And at the mid, where the x becomes what a by 2, so the field is what maximum there. But as you go ahead, the field starts falling. And finally, if I connect all these points, so I will get what variation of the field, which is what equals to 1/2 cycle. And that's why you get what this m equals to 1, or m and n. These are nothing but the number of half cycles in x direction and y direction respectively. So in x direction, there is what 1/2 cycle variation. Now we'll try for what y. So this is y axis. Now whichever point you take, suppose I consider that I will start moving from the bottom plate to the top plate, but at the mid, I will start from here and I will land here. And I will check how the field is going to vary. So now this is y-axis and this is the field variation. Okay. So see, wherever you go from bottom plate to the top plate here, the field strength is going to remain same. Field is not going to change. The same field is here and here. Like here at the edge, here the field is 0, whether you're at the bottom plate or at the top plate, but the field is 0 here, right? So similarly at the mid also, the field intensity at this point is going to be same. Okay, that depends on what is the voltage and what is the separation distance. That is what B. So between top and bottom, V by B, that is going to remain same. The electric field intensity is going to remain same. And on the extreme right, if you go, then the electric field is what 0, like this. So it means that there is no variation in y direction. That's why n equals to what 0. This is how you get what TE10. And similarly, TE01. TE0 means what? There is no variation in x direction, and there is 1/2 cycle variation on the along the y-axis. Okay, so that is what TE01 mode means. What if the orientation of the field, like if suppose I show it here, if suppose this is a width, this is height, and the electric field is what something like this. Now they are horizontal and maximum at the mid, but as you go towards the bottom plate or towards the right, the top plate, the field intensity drops to 0. Now if you move from bottom to the top, then there will be what 1/2 cycle variation of the field, but in horizontal direction there won't be any variation in the field, provided that you are fixing your point, then only. So this is how you get what TE01 mode. So this is all about what is mode and what is the significance of these numbers. So now, as I said that the largest wavelength, when your waveguide is what operated at a largest wavelength for which there is possibility of what propagation of power from source to the generator. So in that case, the variation of the this field is what like this here, right? It is equals to what 1/2 cycle, right? So now since you cannot operate your waveguide at larger wavelength than this, so this is the maximum possible wavelength which can be at which you can operate your waveguide, and the mode is suppose TE10. This is going to happen only for TE10. It is not going to happen for any other mode. So this TE10 mode is also called as dominant mode. Okay, so dominant modes are those modes for which the wavelength is largest, or you can say the frequency is smallest. But if you'll try for what TE01 mode, then you will find that the wavelength is what? Smaller than the wavelength which you will get in TE10 mode. That's why TE10 is dominant mode, not TE01. Means any mode for which the wavelength is largest and still there is what propagation of power from one end to the other end. Then that mode is only called as dominant mode. Okay. And now we'll see how this, what are the formulas related to this, and we'll take one or two numerical in the next session. So this topic will get over. If you have any query, you can raise.
Sir, can we operate waveguide at DC?
No, it's a single conductor transmission line. To operate any transmission line with DC, you need to have two conductors.
Okay.
Okay. Is there any further question? Okay. I'll just give some instruction. All of you please listen it very carefully. While writing, as we have to maintain the attendance, while writing your name, I'll give one suggestion that first you write your division, that is A or B. So it is very easy for us to take the attendance, because Shastri sir is responsible for B division and I am responsible for A division. So accordingly, we will do it. So all of you, maybe from afternoon we have a session at 3 to 5. So we will talk about the lab. So we will give the instruction that we will discuss the topic, that how we can do. And today we have planned to discuss for the 2 experiment, so that you people can do it. This is the one thing. So we will explain you the technology or the theory part or the related part, and then we will give you the assignment or the experiment, mainly experiment, that you have to upload on the Google Classroom. So for the naming, what you have to do, you have to first write your division, that is division A or B. So all A division will be at the top and B division will be at the bottom. So it is easy for us. And then without space, you can write your number, 36, 45, whatever your number that you write. Suppose your number is 6, so you have to write 06, 07, whatever it is. 1 to 9 number, so you write 0 or 2, 03, 04, 05, whatever it is. So it will be easy for us to maintain the attendance. So in the afternoon session, I'll see all the students to be in this format. As I told in the morning, you all have to be on time, because the problem is we are trying to do our level best, because in the morning I trying to log in from the tablet as well as from the laptop, because my laptop is not touch screen, and to manage the login and all this, Shastri sir is doing login from the his